My name is Hashcat. I'm the author of Hashcat. I have not prepared a lot for this talk. The only thing I made is the slides, and everything I do now is to improve my talk. So I just start. I believe this slide go to the tools. So this is all the tools you know from the Hashcat tool. Hashcat is a CPU-based cracker. Also, Hashcat Plus is GPU cracker. It's something like Hashcat CPU, but it works on GPU. Also, Hashcat Lite is a GPU cracker, but it's not made for real password cracking. It's made for competition. So one of the things of Hashcat is I'm not just trying to code a program that is made for password cracking. It's also made for competition. So since I'm a coder and not a hacker, for me it's important to have a tool to compete with other coders. And also Hashcat Lite is a competition cracker because also Hashcat Lite is only focused on performance. Hashcat utils is a set of utils that you can use when you are using when you are doing a lot of password cracking. You have the problem that you have to modify your word list sometimes, or that you have very special situations, and you have to deal with them. You saw patterns in the cracked passwords that come out, and the Hashcat utils you can modify your data you are using for the inputs that you use for Hashcat. Mass processor and step processor are both standalone programs, and that is the one. Okay, I will start with masks. Masks are one of the basic things on that all Hashcat programs use. Instead of using simple thing like instead of using key space that you think of like a ZZZ, which is very intuitive, that you want to brute force. You have to think if you are trying to make to tell a program what key space to generate, then you have many problems. The first thing is you have to tell a program which key space, how big is the key space, how great is how big is the how long is the password. That's it. In this case, it's 3. A to Z it's 3. It's a fixed length, and this is simple. So if you want to tell a program to generate exactly this key space, it's simple. You have 2 parameters. But if you know something about that password, for some reason, like you know something, like show us something or so, something about that password. In that case, for example, you know the 194 is that. How would you tell a program to answer this thing? So you would need another option, and in that case the option to add a sort to the password. And so you have at this point in time you have 3 parameters. You need the char set, you need the length, and you have the sort. So this is still intuitional, but you have already 3 parameters. For example, if you have even more information about the password, like you know the password is always an uppercase, you need another parameter, like a 4th parameter, and all things go on and on. So instead of having even more parameters to tell a program with a key space to get generated, there are masks. And with masks, you do not need all these parameters. You just need to know how to write masks. So why don't use regular expressions? Well, they are too slow. If you think about Hashcat in MD5, for example, it generates almost 778 billion candidates per second. You cannot do it with regular expressions. So if you have 2 or 3 or 4 GPUs, it gets even better, faster. So you need a syntax that is easy to write for the user, and you need a syntax that is easy to understand for programs to generate. So mask is something in the middle. The mask processor is a standalone program like Crunchers, but it uses masks as a syntax. And yeah, it just needs at least one parameter of the mask. There are other parameters you can use, like a starting point, ending point, if you want to distribute your key space. And you can use mask processor, for example, if you want to feed our crackers by Hashcat in that case. The MP64 is a mask processor, and the first parameter is one of the masks. In that case, it's a lower digit. That's what you pipe it to aircrack, and that way you are able to crack like WPA passwords with a mask, because by default you cannot crack with aircrack WPAs with brute force. This works with Windows Book. Okay. You can also use mask processor to generate rules. For example, if you want to generate rules that append something or repend something, you need a lot of lines per rule. So instead of writing them, you can let mask processor generate them for you. So in this case, I want to prepend all letters, and I want to append all digits. That makes a total combination of 260 rules. And if I want to write that, I have to open the text editor and write 260 lines. Much work, and also very the possibilities to do something wrong is also very high. So let mask processor do it. It's very simple. You use the prepend char, and you say $L, it will generate all A to Z variables, and you say also $E, and in combination to that 26 variables from $L, it will generate 260 values, rules. Okay. Yeah, it's very often the case that when you crack some hash list, then you see some pattern in that hash list, and then you have to crack the problem: how can I tell the password cracking tool to make use of the patterns I've identified? And that means very often that you have to write rules. Instead of writing rules, you can use mask processor to generate the rules. The mask processor is very fast, so that's one of the best parts of it. It's so fast that you can feed nearly every CPU-based cracker with it, because there are no CPU crackers that can do around 50 million hashes per password. There are some, but the most cannot. Or if you are writing a password cracker, you can use mask processor to do the password generation part of it. You can concentrate on the password hashing phase. The stats processor is something like a mask processor, but there's one difference. It uses markup chains to improve the order of the generator of the candidates to generate. And yeah, it's the number of total output candidates is exactly the same as with math processor, unless you change the stressor. Okay, let's go to the attack modes from Hashcat. I will not explain dictionary and brute force, you all know it. And I will only talk about advanced attack modes. The combinator attack, for example, one of my favorites, is very simple. You have not one dictionary, you have two dictionaries. You have the first dictionary, that's called the left dictionary, and the second, that's called the right dictionary. And every word from the right dictionary is appended to every word from the left dictionary. So the total numbers is just a multiply. So here's an example of that. You have a dictionary which contains Lucy and M, and if you run this dictionary on both sides of Hashcat in the combinator mode, you produce both variants. So you can improve the candidates by using rules. You can use rules that are applied before the combination is done. So if you say you append a dash to the left to every word, then you can do the separator child. At that case, you can use every char. You can even reverse whatever you want to do with it. So combinator attack is very efficient against passphrases. Passphrases are one of the things that mainly praise for the perfect solution for passwords. They are good, but there is a way to crack them. It's with the combinator attack. So if you have a dictionary that contains all these words, they result, at least these are real passwords that I cracked with from some leaked hashes, and they result in all the combinations at least, but also in them. So and you can generate passwords really easy with them. And like with all attack modes, they also produce results you do not expect. So a good attack mode, in my opinion, produces the candidates you think of, but they also produce candidates you do not think of and crack something with it. Like when I was making this slide, I was cracking some hashes, and I also cracked this one, and I was thinking, yeah, what's going on? That's just one word. So the thing is, the password had a space on the end. So it cracked it because space was part of the dictionary. So, yeah, that was one of the cool things. Another attack mode is a data attack. It's a very complicated attack, and I cannot go too deep into this. There is a video. There are many videos about the table attack. You can see them online, but the table attack is made very good. It's a very good thing to crack, like international passwords or talk case passwords. And you can combine them with something like you can crack internationalized passwords plus leet speak ones. So if someone has like a German word and he leet speaks it, at the same time you can crack them. The table itself, the configuration of the table is very simple. You have one char on the left side, you have n chars on the right side, and for every char you have on the left side, it produces the number of candidates on the right side. So as you can see here, the A is on the left side, and you say make small a's to big A's, make small a to an F. to an egg or to that thing which looks like an egg. So if your dictionary contains a meter, only the small r is used, because if you want to iterate through that A, you need a big A at that, a capital S A. So this A is here, this add is here, this add is here, and so on. So the topic case is one of the easiest attack modes. It was in Hashcat CPU since ever. It just generates all toggle variants of a word. But later we found out that a simple toggle case is not bad, but there is a better way to write toggle cases. Like when you generate a password and you look at it, at the password, the number of uppercase letters and lowercase letters is usually not the same, or at least there are less uppercase letters than lowercase letters. And with a standard toggle case attack, you go through all variants. So this is not really efficient, because you don't need, if you have a word with 5 letters, you don't need the variant with 4 uppercase, because it's very unlikely that the user trusts it. You want only 3, 2, or 1. So instead of using an attack mode, you use rules, because with rules you can do an uppercase conversion. And if you create a large number of rules that change the case in every letter, then you can generate the same result, but with less tries. And with less tries, you have a faster attack. Okay, the target case is not part of OCL Hashcat, because you can simply pipe with Hashcat to OCL Hashcat. Very simple. Yeah, another feature of OCL Hashcat Plus is that you can use stacked rules. In that case, I'm stacking a toggle-based rule with a lead-free rule, reducing it. These are real passwords. In these candidates. So they look very complicated, but they are very simple. So this is a way to attack those passwords. The permutationless attack is something that never worked really well for me. I thought it would work very good, but it didn't. So I removed it from OCL Hashcat, but I'll show you what the idea was behind. So a simple permutation, I think this is clear. Result is, for example, if you have this word in your dictionary, it results in all these candidates, including ours. But these are passwords that could be something that a user has chosen. So I thought maybe this is a way to produce candidates in an easy way. Because it's always the problem is always the same. You have to feed the GPU with a lot of candidates, and so you have to produce them all the time, and you have to produce them fast. So I thought this was a way, but it didn't work. If you really want to use it, it's still in Hashcat CPU, and you can find it through the Hashcat. Fingerprint attack again is something really complicated to explain. There are also videos, and the fingerprint attack, the main goal of this is to do automated attacks. So you do not want to write rules or think about what could the user have closed for his password. You just want to have the hash list, and you say hash can do something. So you can use the fingerprint attack. To do the fingerprint attack, you need the Hashcat utils, and with the Hashcat utils, there's a tool that is called Expander. which is the heart of the fingerprint attack. This was used in 2010 in the first Crack Me If You Can contest, and it made us more because with the fingerprint attack we found new patterns again all the time, because it is, if you're in that contest, you have an idea, you have another idea, all the people have ideas, and after 5 hours you have no ideas, and you don't know what to do. So the good way is run fingerprint attack, and it will generate something for you, and you will find new patterns that way. Okay, the rule-based attacks, very simple. They are very old. I think they have been introduced with Crack 4.0. It's just a little programming language, and you are able to do very targeted attacks, like to say add a 1, add a 2, or reverse the password, or whatever truncated. It's a very efficient thing. So if you have to attack a very slow hash like TrueCrypt or WPA, you cannot use combinator attacks or fingerprint attacks, but you can use at least rule-based attacks. There's the full set of rules that Hashcat supports are in the Hashcat wiki. There are like 20 or 30 functions at all that you can use for programming the engine. And yeah, they are all in the wiki, including in some examples. There are also examples in the rules folder, and well, there are more than examples because they are really good rules. So if you want to attack something, take a look at the rules folder. There are some really good rules inside there. Okay, so Hashcat has a debugging function. So this is very unique because you can output the words that have been used for the generation of a candidate that actually cracked the password. So if you want to analyze which words have been very efficient in combination with some rules, you can use the debugging function. It will write the word for n times, it cracks the password into a file. And the same is true for the rule. So if you want to find out which rule inside the rule file was very efficient, you can use the debugging feature, and it will output the rule n times the number it found that it cracked the password. Okay, and the second rule of also Hashcat Plus very interesting because you can, it's not really, so you can say you have many rules in the command line, like a toggle or a lead speak, and it's not executed in a sequence. So it's like a combinator attack. It appends every rule to every rule. And by doing this, you can generate attack modes yourself, because you can generate in an easy way a lot of candidates on the GPU side. It's not calculated on the host side. And it makes it also very unique, because also Hashcat is the only program that has GPU engine and root engine on the GPU. So there are some examples. You can use it as a hybrid attack. There's a hybrid folder, and in the hybrid folder there are some rules. And these rules are just appending numbers or prepending numbers. And you can say append letters, append more letters, and prepend numbers. So this is something that many people like to do with a triple combination attack, but it's more efficient to do it with rule-based attack. And one of my favorites again is the hybrid attack, which is something that people do. We all know that people use birthdays, years, and append it to their passwords. So if you want to crack them, you could use rules. But if it's a number which is not inside the rule, like if it's not a birth year or it's some very unique number that only that person knows, you will not crack it with rules. But with hybrid attack, you can attack it in a way that you say you have a dictionary on the one side and you have a mask, like explained before, on one of the sides, on the left side or the right side. Okay, here's one of the examples. So, people, these are again real life passwords. People made these passwords, and to crack it, you have a dictionary that should contain Julia password 1 in that case, and New York, and this mask is appended to each of the words inside the dictionary. So you have the digits, the symbol, here's the symbol, here's the digits, and you append 3 of them. So in that case, it wouldn't be enough because you might think that because there are 985 is only 3, but if your password contains the your dictionary contains the password Julia 1, you will crack it. And it's very likely you have it in your dictionary. Yeah. And again, with the attack modes that crack the stuff you don't think of, the hybrid attack is another one. In my dictionary, I had only the cat, and I had to crack the cat head. So with hybrid, it added head because head is inside the key place of LLL. So it's like a combinator attack, but it wasn't supposed to work like that. But that's a good thing with these attack modes. They produce stuff you do not think in the first place. Yeah, and here's another example. So I had phone in the dictionary, and I had this mask which produces tele. So I cracked telephone. Yeah, you should remind us because this is super efficient. This is really one of the most efficient attacks against large unsolved attach lists. So, if you want to use these candidates that Hashcat can produce, and you want it with another cracker, because another cracker can crack an algorithm that Hashcat does not support, Hashcat has an std out parameter, and you can see other crackers like John, for example. Or if you are calling your own cracker, and you do not want to concentrate on the password generation part, which is bigger part of the password cracking, and you want to concentrate only on the cracking part, you can use Hashcat for the password validation. Yeah, and then I often face a problem that I have started an attack, and it is running, and it is running, and it is not producing anything. And I'm starting to think, did I have everything correct? Is the program correctly working? So to ensure that, you can use STDO and to get a better understanding if the attack you started is really doing what you wanted. So again, use the STDO and check the output planes if they are doing what you wanted to do. Here's an example of that. Just create a rule, append a 1 to something, use std out, and you see all what you should see, that all your words from your dictionary have an up and 1 method. Okay, that's it.